Hi students, welcome to our physics class. This is current electricity part 5. In the previous class, we learned about some very important 5-mark derivations. In this class, we are going to discuss about resistor, different forms of resistor, and very important topic, that is color code for carbon composition resistor. Okay, well, let's start today's class. Okay, first let us discuss about the meaning of a resistor. Actually, a resistor is a circuit element which offers certain opposition to the flow of current in that circuit. That is the meaning of resistor. Resistor is nothing but a circuit element which offers certain opposition to the flow of current in that circuit. Resistors are available in different forms. They are number one, that is carbon composition resistor. The first one is carbon. This is a carbon composition resistor. And the second one is the metal film resistor. This is another form of resistor. And the third one, that is wire wound resistor. So the first one, carbon composition resistor. Second one is metal film resistor. Third one is wire wound resistor. Actually, this is also called rheostat. So what is the meaning of rheostat? Rheostat is a wire wound resistor. Its resistance varies from minimum to maximum, right? So what is the function of wire wound resistor? Actually, this one varies the current and voltage in the circuit. That is actually the function of rheostat. So what is the function of rheostat? It varies current and voltage in the circuit. What is the meaning of rheostat? That is the wire wound resistor. Its resistance varies from minimum to maximum. Okay, what is the meaning of resistor? Resistor is a circuit element which offers certain opposition to the flow of current in the circuit. From three forms, the carbon composition resistors are used extensively. Why? Because they are quite cheap and their physical dimensions are small. Actually, the resistivity of carbon, is 3.5 into 10 power minus 5. What is the unit of resistivity? That is ohm meter. So this is actually the value of resistivity of carbon, that is at room temperature. So they made from a few ohms to 100 mega ohm. Okay, the next a very important concept, that is color code for carbon resistor. So actually, the resistor has set of concentric rings. Resistor has set of concentric rings of various colors on it. What is the meaning of resistor? Resistor is a circuit element which offers certain opposition to the flow of current in that circuit. This is a carbon composition resistor. It has the set of concentric rings of various colors on it. So, by using colors, how to find out the value of resistance of the given carbon composition resistor? That is very important. So the first very important point is the colors of the first two bands indicate. The colors of the first two bands indicate the first and second significant digits of resistance. So first, a very important point, the colors of first two bands. The colors of first two bands indicate first and second significant digits of resistance in O. The second very important point, the color of third band indicates the number of zeros follows the first two digits. The colors of first two bands indicate the first and second significant digits of resistance in O. The color of third band indicates the number of zeros follows the first two digits. And the third very important point, that is the color of fourth band indicates tolerance. The color of fourth band indicates tolerance. The last one is in the absence of the fourth band, the tolerance is in the absence of fourth band, the tolerance is plus or minus 20%. So these points are very important to find the resistance of given carbon composition resistor by using the color code. Okay, so these are the colors. So these colors can be remembered by using a code. Okay, how to remember color code? That is very important. B, Roy, go to Bombay. B, so this code is very important. Is B, Roy, Roy, go to Bombay, has a very good wife, wearing a gold, silver necklace. So actually this is the code. Okay, so B Roy, go to Bombay, has very good wife wearing gold, silver necklace. Okay, so here B means black. B means black. Next B. Actually, this is the first letter of the color. What is this? The first letter. First letter of color. First letter of the color. So B means black, next B means brown, R means red, O means orange, Y means yellow, G means green, B means blue, V means violet, G means gray, W means white, G means gold, S means silver, N means no band. So these colors can be remembered by using this code. What is that? B. Roy go to Bombay as very good wife wearing gold silver necklace. In this way, we have to remember color code. Okay, what is the first point? So this is very important. The colors of first two bands. The colors of first two bands indicates the first and second significant digits of resistance, that is in ohm. The color of third band, actually this is multiplier. The color of third band indicates the number of zeros follows the first two significant digits. Okay. So the color of fourth band indicates the tolerance. Tolerance in the absence of fourth band, the tolerance is plus or minus 20%. Okay. So let us take the first example. So this is a carbon composition resistor. Carbon composition resistor. This resistor has colors. What is the first color here? What is the first color? The first color is brown, right? First color is brown. First color is brown. Second one is black. Second one is black. Third one is gold. The last one is gold. Okay. So actually this is the color sequence of this given carbon composition resistor. Okay, now use these 4 points. By using these 4 points, we have to find out the resistance of this given carbon composition resistor, right? So R is equal to the colors of first two bands indicates what? First and second significant digits of resistance in ohm. So what is the significant digit of brown color? That is 1, right? Look at this chart. This is color code chart. So this is first significant digits. So this one is second significant digits. So this is actually the multiplier and this is tolerance chart. This is first band significant digits column. So brown means the significant digit is 1. 1. So black means the significant digit is, now look at the second column. So what is the significant digit for black color? That is 0, right? So 10 into. The third one is gold. So gold means what is a multiplier? Look at the chart. So gold, what is a multiplier? That is 10 power minus 1. 10 into 10 power minus 1 ohm. Okay. So plus or minus gold. The color of fourth band indicates tolerance. So what is the tolerance for gold color? That is plus or minus 5%. Plus or minus 5%. Okay. So 10 into 10 power minus 1. 10 into 10 power minus 1 is 1. 1 ohm plus plus or minus 5%. So 1 ohm, so plus or minus, so 5% of 1 is how much? 1, actually here first we have to calculate 1% of 1. So 1% of 1 is 1 divided by 100, 1 divided by 100 is 0.01, right? So we want the 5% of 1. So 5% of 1 is 1 divided by 100 into 5, that means 0.01 into 5, that is 0.05, right? 0.05. So this is the 5% of 1. So first we have to subtract this value. After that, we have to add the same value. So 1 minus 0.05, that is 0.95. So 1 minus 0.05. So therefore here the resistance lies between 0.95 ohm to, so 1 plus 0.05, that is 1.05 ohm. Okay, so what is the answer? So resistance value, that is R is equal to 1 ohm plus or minus 5%. 1 ohm plus or minus 5%. So the value of resistance lies in between 0.95 ohm to 1.05 ohm. Okay. So the next example. So now look at this resistor. So what are the colors on this resistor? The first one is brown, right? First one is brown. Second one is black, brown, black. Next one is black, brown, black, black, gold. Okay. Okay. So R is equal to. So brown means what is the significant digit? Now look at this column. What is the significant digit? For brown color, that is 1. Black color, 0. The colors of first two bands indicates what? The first and second significant digits of resistance in ohm. The color of third band indicates number of zeros follows. So here third color is black. So what is the multiplier of black? That is 10 power 0. So 10 into 10 power 0 ohm. So plus or minus 5%. So R is equal to 10 power 0 means 1. So this is 10 ohm plus or minus 5%. Right? So R is equal to 10 ohm, 10 ohm plus or minus. So 5% of 10 is 10 by 100, that is 1 by 10, 0.1 into 5, 0.5, 0.5, this is 5% of 10. So therefore, the resistance lies in between 10 minus 0.5, that is 9.5 ohm to 10.5 ohm. Okay, what is the answer? So that is R is equal to 10 ohm plus or minus 5%. The value of resistance lies in between 9.5 ohm to 10.5 ohm. Okay, now look at the next example. So, example number 3. So, what are the colors on this carbon composition resistor? The first color is green, right? First color is green. Second one is red. Third one is orange. Third one is orange. And the last one is gold. Okay. So or is equal to the colors of first two bands indicates the first and second significant digits of resistance. Green means the significant digit is 5, right? Red means what is the significant digit? 2. So 52 and 2. So orange, the multiplier, that is 10 power 3. 10 power 3. So ohm, gold means tolerance, that is plus or minus 5%. So or as equal to, so 52 into 10 power 3 ohm, so plus or minus, so 5% of 52 into 10 power 3, so 52 into 10, right? So 520 is actually, that is 1% of 52 into 10 power 3. 520 is 1%, but we want the 5% into 5, that is 2600. So that is written in the form of 2.6, okay, 2.6 into 10 power 3. This is actually the 5% of 52 into 10 power 3. So our value lies in between, or value lies in between. Where to where? 52 minus 2.6, 52 minus 2.6, 49.4 is 49.4, 49.4 kilo ohm to 52 plus 2.6, that is 54.6, 54.6 kilo ohm. So this is the range of resistor. Okay. What is the answer here? The value of resistance of the given carbon composition resistor, that is 52 kilo ohm, 52 kilo ohm plus or minus 52 kilo ohm plus or minus 5%. So the value lies from 49.4 kilo ohm to 54.6 kilo ohm. Okay, next example. So this is example number 4. Now, what are the colors here? Colors are red, 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 and last one is silver. So red means significant digit is 2. Again, red significant digit is 2. So red means the multiplier 10 power 2, 10 power 2. Silver is plus or minus 10%. This is the tolerance. So our value is, let us consider this one as 2.2 into 10 power 3 plus or minus 2.2 into 10 power 3 ohm. That means 2.2 kilo ohm plus or minus 10% of 22 into 10 power 2. 1% is 22 into 10, that is 220. 220. So 220 means 2.2 2.2 into 10 power 2. Okay. So R is equal to, this is 22 into 10 power 2 ohm plus or minus 2.2 into 10 power 2. So the resistance lies from way to way. 22 minus 2.2, that is 19.8. 19.8. 19.8 into 10 power 2. It means 1.98 kilo. Okay. 2 to 22 minus 2.2, that is 19.8. So 22 plus 2.2, that is 24.2 into 10 power 2 ohm. So this can also be written in the form of 1.98 kilo ohm to 2.42 kilo ohm. Okay, right? So what is the answer here? R value is 2.2 kilo ohm plus or minus 10%. The resistance range 1.98 kilo ohm to 2.42 kilo ohm. So this is the value of R, right? Okay, now look at the next example. So here, what are the colors? The first one is yellow, right? The next one is what is this? Violet, yellow, violet, and the third one is orange. So here there is no fourth band. The absence of fourth band means what is the tolerance? Plus or minus 20%. So the value of resistance is yellow means the significant digit is 4. Violet means the 7. 47 into, this is multiplier. The color of third band indicates multiplier. So orange means the multiplier is 10 power 3. 10 power 3 ohm plus or minus 20%, right? So 47 into 10 power 3 ohm plus or minus. Here we have to find out 20% of 47 into 10 power 3. So first we have to calculate 1%. It is 470, right? 470 into 20, 9,400. That is 9.4 into 10 power 3. So this is 20% of 47 into 10 power 3. So resistance lies from way to way. 47 minus 9.4, 37.6. 37.6 kilo ohm to 47 plus 9.4, that is 56.4 kilo ohm. So this is the resistance range of this carbon composition resistor. Okay. So the value of R is 47 kilo ohm plus or minus 47 kilo ohm plus or minus 20%. The resistance range 37.6 kilo ohm to 56.4 kilo ohm. Okay, the next example. So now look at this carbon composition resistor. What are the colors? First one is brown, right? First one is brown. Second one is black, brown, black, brown, black, and red. After that, last one is silver. Okay. So brown means what is the significant digit? Brown means the significant digit is 1. Black, the significant digit is 0, 10. Into red multiplier, that is 10 power 2. 10 into 10 power 2. Silver means the tolerance, that is plus or minus 10%. Okay. So R is equal to 10 into 10 power 2 ohm plus or minus. So 10 into 10 power 2 is 1000. So 1% of 1000 is 10. So 10% of 1000 is 100, means 10 power 2. This is 1% of 10% of 1000, 10 into 10 power 2. So the resistance lies from where to where? So 10 into 10 power 2 minus 1 into 10 power 2, that is 9 into 10 power 2. Okay. So 10 plus 1, that is 11 into 10 power 2 ohm. So the resistance lies from 900 ohm to 1100 ohm, right? What is the answer? What is the value of resistance of this carbon resistor? Or is equal to so this is 1 kilo ohm. 10 into 10 power 2 means 10 power 3, that is 1 kilo. 1 kilo ohm plus or minus 10%. So the value of resistance lies from 0.9 kilo ohm to 1.1. This can also be written form of, so 0.9 means 10 power 3, right? 0.9 kilo ohm to, so this value is also written in the form of 1.1 into 10 power 3, that means 1.1 kilo ohm. Okay. Okay, the next examples. Write the color code of the resistor of 4.7 ohm. Actually, it is the reverse process. Actually, here the value of resistance is given, that is 4.7 ohm. So this value that can also be written in the form of 47 into 10 power minus 1 ohm. So 4 means What is the color? That is yellow, right? 7 means what is the color? That is violet. 10 power minus 1. This is multiplier. Means the color is gold. So this is the color code of the resistor. Yellow, violet, gold. And the second example, a resistor has a resistance of 120 ohm. What is the color sequence of the bands on it? The resistance is 120 ohm. It's written in the form of 12 into 10, right? So 1 means color brown, right? 2 means the color is red. 10 for 1 means the color is brown. This is the color sequence of this resistor. Having resistance 120 ohm. Okay, the next very important topic, that is temperature dependence of resistance of conductor. How does the resistance of conductor depends on temperature? Actually, in case of conductors, as the temperature increases, resistance also increases linearly. So as the temperature increases, this is RT graph, resistance in ohm, that is taken along y-axis, temperature in degree Celsius, that is taken along x-axis. But at 0 degree Celsius, resistance of conductor at 0 degree Celsius, resistance of conductor is not equal to 0. As the temperature increases, the resistance of conductor, that is also increases linearly. This is the value of resistance at 0 degree Celsius. Let's consider R naught is the resistance of conductor at 0 degree Celsius, and RT is the resistance of conductor at T degree Celsius. So at this point, let us consider temperature, that is T degree Celsius. Resistance is RT. RT is the resistance of conductor at T degree Celsius. So here, what is the increase in resistance? Very important. Increase in resistance, or change in resistance is RT minus R naught. RT minus R naught. Okay. So this increase in resistance, change in resistance depends on two factors, that is directly proportional to R naught. That means the original resistance, and even that is proportional to change in temperature. Change in temperature is T minus 0, that is T. Call this as equation number 1, call this as equation number 2. Now combining these two equations 1 and 2, we will get RT minus R naught is proportional to R naught T. That means RT minus R naught, remove the proportionality, we will get the proportionality constant, that is alpha. Alpha is proportionality constant. This is called temperature coefficient of the resistance of the conductor. So this equation can also be written in the form of or T is equal to or not plus or not plus or not alpha T. So or T is equal to or not is taken as common, that is 1 plus alpha T. For this as equation number 4. So for this as equation number 3. Now from equation 3, so what is the value of alpha? Alpha is or T minus or not, or T minus or not, or T minus or not divided by, or T minus or not divided by or not into T. So now we can easily define the meaning of temperature coefficient. Temperature coefficient of resistance of conductor means that is a ratio of increase in resistance per unit original resistance per degree rise in temperature. So what is the unit? Unit is per degree Celsius or per Kelvin, K power minus 1. What is this? SI unit. SI unit of alpha is per Kelvin or per degree Celsius. Okay. So what is the meaning of temperature coefficient? Temperature coefficient. What is this? Alpha. Alpha is called temperature coefficient. What is the meaning of temperature coefficient of resistance of conductor? That is the ratio of increase in resistance per unit original resistance per degree rise in temperature. Actually, as the temperature increases, what happens? Resistance increases linearly, but not passing through the origin. At 0 degrees Celsius, resistance of conductor that is not equal to 0. This is the value of R naught. So now here we have to find out the slope. Let's consider this point as A, this point as B, this point C. So what is the meaning of slope? Slope is the ratio of vertical distance divided by horizontal distance between any 2 points on a straight line. So here the vertical distance is BC. BC is RT minus R naught. RT minus R naught divided by, so AC is T minus 0. That is T. So RT minus R naught divided by T, that is alpha R naught. So M value is alpha R naught. Okay, that is the value of slope. Slope of this graph gives alpha R naught. So actually temperature coefficient of resistance of conductor is positive, because in case of conductors, as the temperature increases, resistance also increases. But in case of semiconductor, temperature coefficient is negative, because in case of semiconductors, as the temperature increases, resistance decreases. Okay. So the next very important point, suppose if R1 and R2, or R1 and R2 are R1 and R2 are the resistances, or the resistances of a conductor at temperatures at temperatures T1 degree Celsius and T2 degree Celsius respectively. respectively. So in this case, what is the value of alpha? It is very important. So if R1 is the resistance of conductor at T1 degree Celsius, R2 is the resistance of conductor at T2 degree Celsius, then what is the value of alpha? So by using this formula, RT is equal to R naught 1 plus alpha T. So R1 value, so that is written in the form of R naught of 1 plus alpha T1, right? So call this as equation number 1. And R2 is equal to R naught of 1 plus alpha T2. So call this as equation number 2. Now R2 divided by R1, R naught cancels, 1 plus alpha T1 divided by 1 plus alpha T2. So that cross multiplying. So R2 plus alpha R2 T2, that is equal to R1 into 1 plus alpha T1, that is R1 plus alpha R1 alpha R1 T1. Okay. So actually here R2 is 1 plus alpha T2, right? 1 plus alpha T2. So this is 1 plus alpha T1. Okay. So R2 plus alpha into R2 T1, that is equal to R1 plus alpha R1 T2. Okay. So R2, so R1 is shifted to the LHS, that is minus R1, R2 minus R1. So alpha R1 T2. So alpha is taken as common. So that is R1 T2, right? So this is shifted to RHS, then minus alpha R2 T1. Alpha is common. That means minus R2 T1, right? So finally, we will get the expression for alpha. Alpha is equal to R2 minus R1 divided by R1 T2 minus R2 T1. So this is measured in terms of per degree Celsius. And this equation is very important for CET. Okay, alpha is equal to R2 minus R1 divided by R1 T2 minus R2 T1. Another formula, that is alpha is equal to RT minus R naught divided by R naught T. So what is the meaning of temperature coefficient of resistance of conductor? Temperature coefficient of resistance of conductor means the ratio of increase in resistance, per unit original resistance per degree rise in temperature. Okay, the next topic, temperature dependence of resistivity. So what is the mathematical expression for conductivity? Sigma is equal to n e square tau divided by m. Resistivity is m divided by n e square tau. So as the temperature increases, so what happens to the relaxation time? It is very important. As the temperature increases, actually the relaxation time decreases. What is the meaning of relaxation time, the small interval of time between two successive collisions between electrons or ions in the lattice. As the temperature increases, relaxation time is gradually decreasing. So if the relaxation time decreases, what happens to the resistivity? That is, increases linearly. So in case of conductor, as the temperature increases, resistance increases linearly. Even resistivity also increases linearly. But the conductivity decreases. In case of, this is only in case of metals. In case of metals, as the temperature increases, relaxation time decreases, resistivity resistivity increases linearly, conductivity decreases. Okay, so here let us consider rho is the resistivity of metal at temperature T. Rho naught is the resistivity of metal at temperature T naught. So T naught is lower reference temperature. Usually this value is 20 degrees Celsius. So here what is the increase in resistivity? It's very simple calculation. Increase in resistivity. Increase in resistivity is rho minus rho naught. So rho minus rho naught is directly proportional to rho naught. Call this as equation number 1. And even increase in resistivity is directly proportional to the change in temperature, that is T minus T naught. Call this as equation number 2. So now combining the two equations, we get rho minus rho naught. Rho minus rho naught proportional to rho naught T minus T naught. Rho minus rho naught is equal to, remove the proportionality, we will get the proportionality constant, that is alpha rho naught T minus T naught. So alpha is rho minus rho naught divided by rho naught of T minus T naught. So this can also be written in the form of rho alpha is equal to 1 divided by rho naught of d rho divided by dt. This is change in resistivity. So this is change in temperature. So what is the meaning of temperature coefficient of resistivity of a metal? So that means that is the ratio of, this is very simple definition, the ratio of increase in resistivity per unit original resistivity per degree rise in temperature. So this is the definition of temperature coefficient of resistivity. Temperature coefficient of resistivity is the ratio of increase in resistivity per unit original resistivity per degree rise in temperature. Okay, next, let us discuss about the graphical representation of the variation of resistivity of metal, for example, copper, at the lower temperature. Actually, resistivity of metal increases linearly with increase in temperature, but at lower temperatures For example, this is 50, this is in terms of Kelvin, this is 100, this one is 150. So in this case, the resistivity of copper increases non-linearly. So that is only at lower temperatures. Okay, so this is the graphical representation of variation of resistivity of copper at lower temperature. And this graph shows the variation of resistivity of alloys with temperature. Alloys, for example, manganese, manganese, constantan, constantan, constantan. These are alloys. So in this case, as the temperature increases, resistivity increases linearly. But actually, this is the weak temperature dependence, right? So actually, the manganese constantan use it for making. So this point is very important. Manganese constantan is used for making the standard resistance coils. So why the manganese constantan is used for making the standard resistance coils? Because the resistivity is very high and the temperature coefficient, in this case, the change in resistance is very less. So actually, what is the meaning of temperature coefficient? That is the ratio of increase in resistivity per unit original resistivity per degree rise in temperature. So here increase in resistivity is very less. So that is why temperature coefficient is very less in case of alloys. So that is why manganese constantan use it for making standard resistance coils, because manganese constantan having very high resistivity and very low temperature coefficient. Manganese constantan having very high resistivity and very low temperature coefficient. That is why manganese is used for making standard resistance coils. And this graph shows the variation of resistivity of semiconductor with temperature. So in case of semiconductor, as the temperature increases, resistivity decreases. Okay. In case of semiconductors, as the temperature increases, resistivity, that is, gradually decreases. That is why temperature coefficient of semiconductor is negative. So why temperature coefficient of semiconductor is negative? Because in case of semiconductor, as the temperature increases, resistivity decreases. But in case of metal, temperature coefficient is positive. Here is also positive, but the value is very less. Okay, thank you.